We're here to see a presentation by Laurent Gharda. He'll be giving us a presentation on how the improved manageability of systems, actually read this, how systems management is helping accelerate the adoption of Linux. So without any further ado, let's give him a nice warm welcome to Laurent Gharda.
So, I'm going to be talking about a variety of topics today, all of them having to do with the concept of manageability. So, this is a course outline of the agenda. So first I'd like to talk about what is management, because depending on who you speak with, it has a different interpretation. Then get into what we consider systems management and basically give everybody a primer, which is going to be very high-paced, lots of screenshots, not brand specific, but rather concept in general, and have you all come up to speed. Then talk about the different ways how systems management is being used to generate revenue as a service. Talk about the concept of collaboration, and some lessons learned from my personal experience and those of my colleagues in doing business in the United States and overseas, which might actually surprise some of you, or perhaps not. So real quick, we're a company located here in Belmont. We're in several key regions of the world. It turns out that much of our revenue is coming from overseas, not just the United States. And we have as customers Intel, who's an OEM of ours. We have Cisco, large institutions in China and other regions. So what we do is systems management, and the way we define that is installing the operating system, managing repositories of software and content, assembling your various files, packages and such into what we call stacks, being able to deploy them, monitor your infrastructure, discover what hardware and software assets you have, and so on. And one last company, bravado, is the fact that we won the Linux Journal's Award for Best Systems Management Product at Linux World, and we're very happy about that. And having been bootstrapped and co-founded by Paul Cubbage and Mike Grove and myself, we had a hard time entering a market that had already been well funded by other companies who had been in business for a fair amount of time. And so we decided to focus on Linux from day one. And we also realized that as various management vendors were starting to support Linux, it was always Red Hat and SUSE, now Novell. And so our strategic focus has been to focus on not just managing those, but also on managing the majority of the other popular Linux distros. So I'm not going to go down and enumerate every single one of them, but the ones that you're most likely to find in a commercial environment are the ones that we support. So someone mentioned the latest release of Ubuntu, but we support that, but also all the regional ones. So lots of them in Asia that you may have never heard, but that are generating a lot of sales in opposition to Red Hat and Novell. And basically by teaming up with our systems management software, just about any distro can have parity with Red Hat and their management tools, or Novell and theirs. So business models, we have basically three. So one, yes, we're a proprietary piece of software. There's some philosophical reasons, there's some revenue reasons, and there's some technical reasons why that is. Let me quickly address the technical reason, and whether you want to take shots at it or not, is the fact that unlike monitoring tools, which are basically providing information as to what the status of the device is or performance of the device, systems management as we define it can be highly destructive. And the last thing that we would like to have is for people within an enterprise to basically have access to code, alter it, and have another fellow IT user wipe out the hard drives of thousands of systems, for example. So that is a technical / business rationale why we've kept it proprietary. Having said that, we're also the sponsors of the Webmin project, which I would presume many of you have heard of. And so we've added back to the Webmin product as it is released. We're also going to be introducing in the next few weeks a series of enhancements, some of them completely open source, no strings attached, and free, others open source but with a different type of license, and others get plugins because they provide tangible value and would be based on top of web. Yes?
Could you summarize the number of Linux installations in the US, Europe, Asia, and elsewhere? I just don't know anything about that.
You mean globally?
Yeah.
Well, I would say you're talking about as an industry.
Yeah.
Well, that's going to be a tough guess. I would say that, boy, you guys probably follow these numbers better than I do, but let me tell you in terms of my perceived percentages of where they are. So I would say that in terms of percentage of growth, Latin America, and basically the BRIC countries, which stands for Brazil, Russia, India, China, and Korea, is where the highest explosion of growth is taking place. And that's why those are areas where we've either established offices or localized language to in most cases and so on. I would say that, as we all know, in the United States, Linux on the desktop is still something that's waiting to happen. It just hasn't happened in a commercial environment, in spite of the best efforts of people like Linspire and Xandros, who have, highly capable solutions. But the install base of Windows is something that's really preventing it. On the server side, I would say that it's growing very fast in the United States as well as the other countries. I would say it's growing very fast in Europe. Surprisingly, it's growing less fast in Japan, where money seems to be less of an obstacle, and they're content in paying whether it be Sun or Windows or their local operating systems from people like Fujitsu and Hitachi and others. So I didn't quantify it, but that's my perception of percentages or rough scale of the actions. And last item on this slide is services enabling. So this is a new twist where we are seeing that managed service providers is a type of business that is quite popular in corporate America and Fortune 2000. We're seeing it moving to the SMBs within the United States, but on Windows, because that's what the install base of SMBs have. But we're now seeing managed services as a line of business happening in Asia again on a growing scale. So basically, that summarizes who we are as a company, so enough of the fanfare. So let's talk about what are the different kinds of management solutions. So I was at a talk the other day with the CEOs of SpikeSource and Black Duck and Groundwork, and this was a kind of dog and pony show where we each had 5 minutes to give it our best and everything. And this is one of the slides that I used where, depending on who you speak to, open source management has a completely different meaning. And so the various categories that I've heard, and this is not an inclusive list, is management solutions. Well, if you're creating open source components, you can argue that your solution is CVS or Eclipse or the inherent mechanisms that the community regulates itself, if you want to use that expression. You have some companies that consider management solutions to be managing the intellectual property / licenses / export worthiness vis-a-vis encryption and so on. And so you have people like Black Duck and Palamita that do that. Validating interoperability, so SpikeSource has been making a living doing that, OpenLogic also. More and more now assembling completely working stacks and supporting them, so you have SpikeSource and then your run-of-the-mill ISVs, including Oracle, although hardly run-of-the-mill. Managing virtual systems, so this is something that's getting a lot of press right now, and that can be a completely separate category of management, depending on your perspective. Managing services. They call themselves systems management or configuration management, but basically turning on and off Apache or changing passwords on 15 JBoss servers at once and so on. So you have a series of vendors that are focusing on providing that very specific type of functionality. Monitoring, so based on Nagios or Mon, you have Groundwork, you have Xenos, and you have a larger number of companies there, and of course the commercial people like BMC with Patrol, HP OpenView, and so on. And then finally, under systems management, the way we define it, which is really cradle to grave from installing the operating system to monitoring the infrastructure as well, then you have different classifications there. And so at the enterprise, targeting the Fortune 1000 or the Global 2000, IBM Tivoli, Computer Associates, Unicenter, HP OpenView. Highly capable products, typically have a reputation for being expensive to acquire and expensive to implement, but they will be able to manage and monitor every device with every operating system, with every architecture known to humankind. Then you have another class, which is the data center people. So again, this is not an all-inclusive list, but you'll have people like Opsware, BladeLogic, Sun N1, and Symantec has some products in that area as well. Then another category that we see are people who've really focused on Windows Desktop from the very beginning and may or may not have spread into other operating systems or device form factors. So Altiris is a pretty big name. Landesk, which has been acquired off and on by Intel, spun out and then recently acquired by Avocent, is a company that specializes there. And then finally, Linux specialists. So you have, of course, OpenCountry, Webmin, the project sponsor. What we run into as far as competition most often would be the Red Hat Network modules, not the Red Hat Network itself, which is basically the equivalent of the Microsoft Update Service, but it's these additional paid-for modules that we compete with, and then ZenWorks from the Bell. So if we take a look at the whole ecosystem of open source types of products, and if you take a look at the same time at the various phases of software utilization, you'd start with the creation of the software or the solution. And so there'll be some distinct steps, so software development QA, software compliance, which is something that is really emerging as a trend. So we, for example, use Black Duck at OpenCountry to make sure that open source doesn't find its way into our proprietary software, or to make sure that we are respecting the various kinds of licenses and so on. And Paul is driving our IT compliance effort at OpenCountry. And then packaging and creation of the final solution. So I categorize these as being the solution creators. And they can be internal, they can be captive, they can be commercial, they can be open source. There's a whole variety of them. And then once a solution has been created, well, it's going to be consumed. So the solution's consumers are going to be just about anybody, and I'm focusing really on enterprise, SMB, government, education. One could argue consumer as well, but again, in the Linux environment, that's rather limited in comparison. And here, the various stages of the life cycle are very different, where you start with a pilot or a staging environment of software that you're bringing in to your organization, then focusing on the rollout, and then the ongoing carrying and feeding, which is updating, providing patches, doing monitoring, discovery, and so on. And so basically, OpenCountry focuses on all of these different these parts of the food chain. And we do use open source components like Postgres is our database, JBoss is our app server. Webmin we've incorporated from day one as the mechanism to manage individual systems, but it's really not an essential component of our software, meaning we can operate with them or without them, so we're not really based on them. And then coming soon is going to be Bacula integration to allow you to do backup and restore, disaster recovery, and so on. And again, the key thing is the fact that we run on all these distros. And so this has enabled us to basically be able to compete head-on by partnering with someone in China like CS2C, who has an installed base of hundreds of customers and tens of thousands of servers, and be able to win incremental business because they did not have manageability solutions, because they didn't have the tens of millions it took for Red Hat to develop theirs or developers and so on. So the reason I'm kind of mentioning this is not really as a plug for the company, but rather it's a series of building blocks that will lead to some of the conclusions toward the end of the presentation as to why we're seeing that systems management is enabling the acceleration or the adoption of Linux. And so some of the partners that we have in here would be people like Black Duck and SpikeSource, who again focus on specific tranches of the life cycle. Really in terms of being able to do pilots and staging and rollout and updates, I mean that's what we do, but really what we're trying to focus on best practices, whether it be from ITIL or others. And then in terms of ongoing caring and feeding, some of our customers use Nagios because our monitoring is really just a sidebar of what we do, and Nagios is far more capable. Black Duck would be used in certain environments on an ongoing basis to make sure that software assets that are brought into the enterprise or behind the firewall are not themselves violating any kind of intellectual property or license mechanisms. And then JasperSoft for analytics and so on and so forth. So now we're going to start with, any questions so far? Okay, Systems Management 101. So here are some of the key concepts I'm going to focus on rather than rattle them off. I'd like to show you this slide here. We're basically based on IDC and Gartner and others. The 5-year ownership of a system, whether it be a desktop or a server, it turns out is pretty comparable. 2/3 of it is IT labor costs. And when we talk about all the attention that new hardware is getting and virtualization is getting and so on, when you take a look at the economics of it, it's really nearly a who cares? And so our focus is trying to reduce the overall size of this pie by reducing this size. And when I say we, that means systems management vendors as a community, so to speak. So starting with the first concept, installing the operating system. It's something that is a convenience factor, but it also has the benefit of providing repeatability. And the way we do it is by incorporating the control files from the various vendors. We're not in the business of doing image-based deployment, which is very restrictive in terms of differences between systems, but rather use what the distros have put their efforts into supporting. So on the client side, if it has a user interface, you could go ahead and you can see this is a pretty old slide for Core 2. Wow. And basically hit a number, walk away, and come back 20 minutes, and that's the operating system that you have installed. From the user interface standpoint, what we have is the ability for you to enter the various control files that you would have, upload the CD-ROMs that you have lying around, and then being able to either set a default, so whenever there's a request to be provisioned that comes over the network, that it be provisioned with whatever you set as your default, or on a per machine basis, you can go ahead and tie it to a MAC address and give it a name, so if you yank out your NIC that you don't lose the history, give it your names, your password, how you like to have it set up. Here's a drop box from which you can choose the operating system, the distro that you want to install it. And then finally, a couple buttons here that says, do you want to enable automatic provisioning, yes or no? So the first time it would be yes if you want to use that feature, but then if it's an Oracle database that you're running in a production environment, then you want to make sure as soon as that OS has been installed, you click that to no. So in case you have a hardware hiccup and the machine is trying to force a boot request, that you don't overwrite mission critical data and so on. Or keep it always as yes, because for example, in my QA labs, we provision machines 3 or 4 times a day during our QA runs, and so this is part of the business process where you would have frequent provisioning. That's just part of it.
Provisioning means on a particular piece of hardware, they'll put the whole shooting match on, from operating system to everything else.
Well, actually, it could be that. So it could be the entire operating system and post-install scripts and additional packages and so on. What we recommend is that you instead do the opposite, which is you put the very smallest operating system possible, and so it's common to all servers, all desktops, all blades you would have, no matter what their ultimate purpose is, and that you would then use the concept about reintroducing of software stacks to change this barely working system to a database server or an engineering workstation and so on. And by separating the base operating system from all the packages that you're going to be using to change its purpose, you have a lot more flexibility because you're not now manually editing control files by deciding what goes on it. So provisioning in our sense really means installing the OS, or it could be the whole kit and caboodle if that's how you choose, but then that's where best practices come in. So for example, B of A, they've narrowed down their RHEL 4.x to something like 270 packages, and that's the base install that they have, and then they use a concept of errata, so that would be a stack that they deploy to bring it up to the current level, and then finally a purpose-built series of components software components to change the personality of the system to be a workstation or a server.
Question.
Yes.
You showed the customer pie for open source. If you're buying licenses from Microsoft...
No, that was not for open source.
Oh, that wasn't?
That was in general. I mean, whether it's a Windows or Solaris machine or whatever, it turns out that there'll be some slight variations in the cost of hardware and software, but still it's going to be the labor cost over a 5-year period. That was the small text at the bottom. It's over a 5-year period because the hardware is one time, the software is one time. Yeah, there'll be some maintenance that adds up, but it's really the cost of the labor to care and feed for it.
So the licensing is really a small chunk.
It is. It is. Yeah.
Thank you.
So a concept that we've introduced is the ability to tie in into a systems management product the various repositories that are out on the net, plus the own repositories that you set up. So public or local is a fancy name for FTP or rsync, and the benefit here is that you have the ability of tapping into the various mirrors and have the main database of the system management product on a regular basis go up, find the new packages, rip them open, figure out what all the dependencies are, enumerate those dependencies in the configuration management database that we have, and then throw away the package so that when time comes to deploy it, you go ahead and get it fresh, and you'd always have, for one thing, the latest, and you would then be able to also, as an option, create a local mirror. So that's the equivalent to the Red Hat satellite, where you can bring it behind the firewall and have access to it. And then local repositories would be things like rsync repositories, and so we don't care if it's packages or scripts, config files, JPEGs, content of any type. So it's just all of the various bits that you would have in your environment. So once you have this set up, what you get into is, with the way we do things, is the concept of stacks. So a stack is a predefined by the IT user or by the VAR or ISV series of packages, scripts, files, and so on. And so, for example, a web server stack might be install Apache, copy these config files to this location, run a script to edit these config files, install MySQL, and so on. And so I'll give you a better illustration with this slide here, if you can see it. Sorry, it's a little bit busy. But here are a series of stacks that have been developed. So for example, here's a typical LAMP stack. You have database one, a SendMail one, engineering workstation one. And then inside each one, we're looking at the LAMP one, you're going to have various kinds of files. In this case, they're all packages. And you can move up or down the sequence with which they get installed. For a given packet, for a given file, you can say whether it's to be installed, or if an executable executed, file copy it, or execute a script, and so on. And this is something where the concept of separation of skill comes in, where you have people who are deeply skilled in a certain area who will build these stacks, and then when they're done, they'll lock them to a certain distro to make sure that someone doesn't accidentally deploy it to a Novell machine if it was really tested on a Red Hat one. And you resolve the dependencies based on what's in your repositories. You can then do a test, which is a simulated installation on every machine, or just a few representative ones, and then finally lock it to the distro, and now it's as if it's a single object that you can now deploy onto a machine or 100 machines at once. So you can do the dependency resolution here, I mentioned that earlier. And one thing we consider important, and this is the difference between running an environment where everything is scripted, is that there's a full transaction log of who did what to whom, and I'll get there a little bit later. But in this particular case, you can see that the job was scheduled, it was sent to the agent, it was received by the agent, it's in progress, it's reporting some successes, some failures, etc., etc. So there's a full log of what happens, and we'll talk about compliance a little bit later on, but this is one of the things that comes with typically any systems management environment. Next concept is grouping systems. So nothing really mystical here either, other than the fact that if you're managing more than a couple or 3 machines, it's nice to be able to do operations that take effect on multiple systems at once. And here is where not only can you group machines and have actions taken on them, but the way we've architected our product is that you have the ability to take any arbitrary machine, add it to a group, and that machine will inherit all of the properties of that group. So, for example, you can have a web server group that already has a stack applied to make it a web server, and when you take 5 new machines and you bolt them into the rack, you just drag into that group and they automatically inherit all of the software, the monitoring properties, and so on. And when I say automatically inherit, that's not quite correct. You'll be asked whether to confirm, we're about to do this, we're about to do that, is this really what you want to have happen, and so on. Because there are some cases where you might have Apache 2.0, do you really want to downgrade it to 1.3.x, and in some cases it might be yes, in some cases it might be no. So there's a whole series of truth tables that we have to follow to allow the IT person to have full control over it, yet take by default the what we consider to be the appropriate action. So it's hundreds and hundreds of various scenarios where if I'm taking a subgroup of 10 machines and I'm adding it to another group, and then I'm removing them, what happens, and so on and so forth. And what happens if I install software on a machine one at a time, then I add it to a group, and then I remove it from the group. Well, do I remove the software or not? How did the software get there in the first place? So how every bit gets into the system is recorded and logged, and it gives complete granular control to the IT individuals. And in terms of best practices, we were talking about the Red Hat Network earlier, or the Microsoft Update Service. So in the IT environment, it's typically a no-no to have your machines set to up to date and go outside the firewall and grab what you want when you want to. So we actually don't allow that to happen, and that may offend people, but we really consider that to be best practices. So the IT staff will get notified, however they are, by the distro provider. Then the IT person brings in specific packages inside their environment, puts them presumably on some kind of pre-production repository, vets them, tests them, validates them, simulates them, and then only when they pass the green light do they then get put into a production environment and then get deployed at a specific time, and you have a full transaction log of which machines were online and actually got it, or if they were offline when they come back they will get it, and so on. So again, having really tight control over what bits get pushed when is something that makes a difference in enterprise type of systems management. And when you say enterprise, it's really any kind of environment.
Does that mean you're monitoring what's on machines? and someone comes in, boots a CD, puts a bunch of stuff on a system you've already defined? What happens when it comes back up? Your monitoring system realizes that this isn't right anymore?
What we do is we do periodic software discovery on every machine.
Okay.
So if you go in as root, install a bunch of stuff, we'll know you'll have done that.
Okay.
If you go in and we're not at the tripwire level where we send an alert as soon as a bit changes on the hard drive.
Is it like package level?
It's at the package level.
Okay.
Yeah. And I'll show you some screenshots actually on that. So next is the ability to manage obviously individual machines, and again this might be a little bit hard to see, but we install our agent from our user interface, and so if you're an authorized super user, here's where you put in the root password and the encrypted SSH and root passwords and so on, and you can install the agent, you can stop it, you can restart it, but then here's where you'd be able to figure out what is the hardware of the system, what is the software installed. You can set individual monitoring alerts. You can see the scheduling history or the transaction log. And finally, you can also see the history of a machine over time. So for example, you might take a snapshot on a periodic basis of various machines, and you'll see at what point did a JBoss get updated from one version to the next. Or you might have the same version of JBoss on the machine at time frame T0, and then at T2, but then someone might have removed it in the meantime and reinstalled it, and we'll keep track of that happening as well. So monitoring, I guess we all know what monitoring is. Basically, we do, quite honestly, a relatively limited amount, so we focus on what's really internal to the Linux device itself, so namely CPU utilization by process, disk capacity, swap and memory usage. And the way we've done it is that we've created the concept of a monitor, which is, think of it as an object. And so you'll have the ability, in this case, This is monitoring disk capacity for application servers, which might be different than disk capacity for database servers, for example. Check every 5 minutes. If it's over 70% capacity, send me an email just once. Don't nag me, but if it exceeds 85%, send me an email every time you go out and verify it, and then run a script that, for example, could delete the temp files or whatever it is that you decide to do. So we're not an alternative to scripts. Well, in some ways we are, but we really embrace them. So part of what a customer does when they first get this software is they incorporate the various scripts they have into our repository and then use this mechanism to go ahead and manage the deployment of it, again, to ensure compliance and so on. So a topic that comes and goes, but is really of importance to most CIOs and certainly CFOs, is asset management. So what are the hardware assets I have? What are the software assets I have? What are the applications I have installed? How do I do depreciation on them? What is their age, and so on and so forth. So being able to discover all this information will provide better negotiation capability with vendors. It'll also help you realize in the case of commercial software that you may be either in violation or that you are not using them all, so therefore you could be negotiating and get a better deal next time. And so in terms of assets, so software assets is one example. So here, to your point, we're basically just doing a generic discovery of all the packages on the machine, and we do this on a periodic basis. And same thing with hardware. So that dives me into the concept of diagnostics. And diagnostics means different things to different people. We're focusing really on package level and hardware in terms of what we discover. And so, for example, in this screen here, you're doing a diagnostics, basically doing a software comparison between various machines. So what you do is you take your mouse, you go to a node group, and you say, well, tell me the difference between these 2 or these 4 machines, because they should be behaving the same, yet they're not. So what is the difference? And so if it's all green check mark, and by the way, I'm showing only the differences, or I could show everything, and I'm showing only software, not hardware. And so when you click on any one of these lines, you can see what the values are down below here. So it's telling me here that the package comps has different versions right there. So that's one way of identifying the consistency. Yes?
It's too detailed, but when you're checking for packages and versions and things, do you check down to a bit level to find out, in other words, check whether the file is what you expect it to be?
No, we don't do MD5 verification or anything like that. We assume that what's in the header and in the file name is consistent. We don't go down that level.
Could you find out, for example, the reliability of a Mac store versus a Seagate drive based on the huge amount of data that you have collected?
One could argue that we could, because we stuff everything in this database, and it's a question of writing a report that, in this case, you'd like to identify how often did one get replaced. And so, yes, you could derive that. Do we have ready-made reports for that specific thing? No. Typical things that we'll find is uptime of entire systems, overall performance thresholds being broken by CPU, by process, and things like that. But that's a good idea, a good suggestion for something. You have a question? Sorry. Okay, go ahead.
I have one.
Yes.
When you do hardware, do you go on the disk level, for example, do you go by the disk ID number, like not the SCSI ID, but the serial ID that the manufacturer itself put on there?
Yeah, we do. And so basically we'll discover any kind of property. So right here, you can see that many of these, if they're all green check marks, that means they're the same. If you have an X, it means it's missing altogether. And if they're triangles, that means it's different. So here we've identified that, what does it say, model name for the CPU, and you have 2 P3s and a P4. And same thing, if it's disk drives, you'll see it's an ST something versus an X, whatever. So we do that.
So you're just inventorying the entire product file system, essentially?
That's what we're currently doing. We're in the process of enhancing that. In the past, we've gone to the BIOS, but with the BIOS not being apparent in every hardware environment and the differences, we've kind of gone back and forth. And so where we are right now is at the proc level. which is fine for Linux and Solaris that we're going to be porting to. Won't work for Windows, so and we will be porting to Windows. And so, you know, we have to try to be as independent as possible. So that's why all the open source subsystems that we've used are available on all platforms, and that's why we're writing in Java to the extent we can to be completely transparent. So right now, our management server is running on Windows, it's running on Solaris, but we haven't released it because we haven't tested it, and we can't really do the package management for Windows yet, or for Solaris. We don't understand PKG, or we haven't implemented it yet. So software search is a nice feature. So here I'm doing, you know, search for current stars. So any file in my node group or in my environment will tell me, you know, which versions is it running. Then I can go ahead and on the fly say, well, let me, you know, click on these 5, create a group, update a package on it, delete the group. And so it's a quick way of basically doing group-based manipulations based on specific events that you're looking for. So compliance. So this is something that barely existed a couple years ago, and SOX was a motivating factor for many organizations. So who touched which assets when, who logged in when, and so on. Again, this is at the system level. You have entire companies based solely on compliance, and they would be able to tell you who changed a row in a spreadsheet or touched a SQL table in your Oracle database and so on. And so this particular screenshot is for a given machine, machine vendor, name it, whoever gave it. And so these are the various tasks that were asked. And then here I basically asked for the status details. And so I can see that it's the IT user Alex01, whoever that is, scheduled it. It was sent to the agent. And then as a separate process, the agent receives it. And so we have various software layers between the management server and the end machine. And we keep track of, okay, it was sent, yes, it was received, I started doing this, it's in progress, I received it, and basically, again, the full audit trail of error messages and everything reported back. So business continuity, backup and restore, that's either really exciting or really boring. I mean, it's kind of like hygiene as far as I'm concerned. There are really good solutions on the market, you know, Veritas, Gharda of OpenCountry, and so on. We're going to be introducing a version, as I mentioned, based on Bacula, and that is going to be something that we're open sourcing. And the key benefit here is that even standalone, the version of Webmin, we're calling it OCM Webmin Plus, will have an integration for Bacula, so you can use some extensions we've added to go ahead and discover additional machines in your environment and back them up or schedule them for backup, so the full user interface to do that. Or if you're also an OCM user, then you automatically discover the node group and node hierarchy, and you can go ahead and back it up that way. So security, I raised it just because, well, what about security? So I view security pretty simplistically, and I'm pretty naive about it in terms of, you know, depth of the technology, but there are 2 real elements. One is making sure that the management infrastructure itself is secure. And then, so basically make sure that you have encryption, that you have, you know, at every layer possible, that you have no way for being encrypted and so on. And then you have a separate concept, which is making sure that the machines that are being managed in a secure environment are kept secure. And that's where you need to be able to update them predictably, have audit patterns, and so on and so forth. So I just threw that in there because I usually get asked about that. Virtualization, for me, this is kind of been gone. I mean, it's surprising how much visibility it's getting. In some cases, when you have a very well-run data center and you have on-demand computing needs, virtualization is absolutely essential. And the focus is really more done on the load prediction and the rapid repurposing of virtual machines or physical hardware to meet the needs of the actual users. And as far as systems management goes, to us a VM is just like a piece of hardware. We'll install your operating system, we'll deploy stacks, and whether you decide to grab it and you have, you know, for example, VMware's high-end software, or XenSource does part of this now, but you can grab it from this machine to that machine, you know, we don't even know that happened. So it's really orthogonal to what generic systems management does. So how does this all fit together? Well, in a, regardless of whether it's OpenCountry or not, you'll typically have systems management on a device. It could be a dedicated device. It could be actually make it available as an appliance. In small environments, meaning up to 100 machines, you'll probably have a single hard drive. And you saw that you basically install the agent, and then you basically say, okay, discover the hardware, discover the software, and create your repositories and everything. So this is pretty simplistic. When it gets a little bit more complicated is in large-scale topologies, and this is where business models can also overlap, because now we have to be able to accommodate internal IT with one location, internal IT with multiple locations, outsourced IT with one or multiple, and so on. And so the architecture is basically based on the concept of redundant software components, where you'll have multiple dispatchers or schedulers. You'll have the concept of drop boxes, where a job gets set and is ready or waiting for the agent to come and get it. And as you saw in the compliance log earlier, it was sent to the agent, so that means the Dropbox got it, it tells the main database that happened. Then when the agent grabs it, it says, yes, I have it, yes, I did step 1, yes, I did step 2. So if at any point in time a machine gets interrupted, a network connection goes down, a Dropbox, which is a software, bit bucket really, well, we don't, except we keep the bits, goes down, we're able to recreate wherever the machine was left off. So, yes?
Question, where does customer and user satisfaction come in? Does the system help me or hinder me in getting my job done?
Well, it depends who you mean by the end user. So if you're talking about an IT professional, this helps make your job a whole lot easier. And I'll get into some more stories at the end of the presentation. And if you're in IT management, it makes your life safer. If you're a CIO or a CFO, it prevents you from going to jail, worst case. For Sarbanes-Oxley compliance and whatnot. So it all depends on the view of the perspective. And there are also some geographic types of differences that I'll get into. So I'm still in the SM101 here, but please go ahead.
I was thinking more about the end user saying, gee, the system's too slow, or it's not reliable, or, just typical complaints.
In that case, then this software would help pinpoint the reasons for that. So if you're a desktop user, or say a web user on an application server and you report some performance sluggishness, then they can go ahead and take a look at the monitoring logs, understand you're swapping too much or whatever, or in the case of the desktop user that who knows, your disk is getting too full or whatever, or you have the wrong version, or you didn't update it, or you added some software you shouldn't have, or so it goes both ways. One to help, the other one to scold.
Or here's a fix mode, now you just deploy it all. So that's good.
Yeah. So, how many people write software in the room? Okay. So, let me talk about both the early part of the software life cycle and how systems management applies, and then also talk about it in rollout. And this is something I did for OSDL. They wanted to understand how our software could help them there. So basically, this is how I define the various stages. So software development, QA, pre-production, production, and then ongoing life of the system. So in the software development phase, this kind of software is actually very valuable. Again, whether it be OpenCountry or another brand, as long as it does the same functions. So it allows you to avoid some of your most expensive resources, software developers, from doing undue system administration on the boxes. So, I have some people in my enterprise that I'm paying outrageous amounts of money as software developers, and the last thing I want to have them do is do work that someone being paid half of what they're being paid should be doing. And so, the ability to have streamlined operations, consistency between projects. So again, this comes back to the idea of a bare operating system that's common to all developers. Then various software stacks, for example, productivity, that would be common to everybody. And then tools for project A. So you're using Eclipse, you have these 12 plugins, you have these libraries, and these are all objects that you deploy onto node groups. And so this makes it easy to repurpose machines, to have people change projects. But the big one that gets me is, it doesn't happen in my organization as much as it used to, but an engineer messes up and tries to cover his tracks for a day and a half while his boss is thinking that software development is happily taking place. And so when you have this kind of environment, just fess up and basically reinstall the OS. Don't try to fix, just start from scratch. So redeploy the OS, redeploy the various stacks you have, restore your config files, tap back into your CDS or other source version control, and you're back in business. As opposed to making the project slip by a day because you were trying to compensate for either accidental or some malicious done by someone else. You downloaded something that you shouldn't have, or you brought in the wrong library and it corrupted something, and so on. So it really lets software developers focus on software development. During the QA cycle, basically the ability to do several things. One is to rapidly reprovision each QA system at every time you test your software. And we're pretty fanatic about it just because too many times between test runs there have been little turds left over from the previous build that would not be represented with the customer environment would find. And so by just starting from bare metal each time, you're ensuring that the experience that that the QA people will have will be comparable to what the end customers have. So, did you want to go into the situation you had yesterday, the difference between the test environment and the production environment that you had?
Oh yeah, the problem we had was our production environment has a big IP server with load balanced across a couple machines. The browser sees it as port 80, but the machines are running on a high-numbered port. But for doing the test, we decided to just put on one machine on a high-numbered port. But it turns out that the way that the cookies are set in the application, it wasn't done properly in the event that it was running on a high-numbered port.
Okay. So I don't know if this would have helped in that environment. I mean, you need to have comparable hardware for pre-production.
Yeah, the big problem was just that the pre-production we didn't have another big IP box that we could play with for that, so we sort of winged it.
Got it. Yeah. So what we do is that we have quite a bit of hardware, and then on top of that we have virtual machines. So every Pentium can basically represent 4 to 5 systems on average, and so we're able to multiply that. And again, from our point of view, it's a question of installing the operating system, taking the stacks that were developed by engineering, deploy them, make sure that you have working software as phase 1. This is even before the final packaging of the software, and so on. And we can use to some extent performance tuning, and also importantly is that you can keep track of what software has been tested on what kind of hardware, because we keep track every time you deploy a stack to what machine is it, what is its hardware, and so on. So there's some forensics value in having this kind of discipline. Pre-production, so this is where you now organize your software into stacks, put all the various configuration files, installation scripts, basically massage it, tweak it, do simulated deployments, do actual deployments, lock it to a certain distro or multiples, and now what you have is a really repeatable process. And so when time comes for production, well, it's nearly a yawn because it's really push button accurate. You might want to perform hardware and software discovery, hardware discovery, just to make sure that you're not running into completely incompatible hardware. That's happened to us at the customer site where, gee, we thought that was an x86 machine and it wasn't, so shame on us. This was in a pilot environment, and basically reproduce the steps that you did earlier, and now you have the concept of compliance. Or the other way of putting a machine into production is simply dragging it from a pre-production group and into a production group, and now you've done the same conceptual thing that you would do in having a staging website, for example. Yes?
You mean like your OpenCountry package can go out and set up a customer's machine?
Mm-hmm. Well, it depends which one I set up.
They can subscribe and get a bunch of machines installed.
Well, we don't deliver any kind of service other than training and installation, if you will. But there are companies who are managed service providers who do that. So
if they were selling some kind of product that had a production environment, fine, they could put the whole shooting match on the customer's
absolutely.
machine.
Oh, absolutely. That's the purpose of the software. Absolutely. And so, for example, we have a channel partner in Santa Clara, ASA Computer, They're now shipping our software buried inside the hardware, and they call it an OCM provisioning appliance, OCM management appliance, and they're starting to ship them now to their customers that they've been selling Linux service to for years, and all of a sudden, as a channel partner, they are having an incremental source of revenue, which is the margin of the software, plus happier customers and all that, so everybody wins in the process. Yeah. So, and then later on, we already talked about it, deploying patches, updates, and all that is another stuff that systems management in general should do. So, let's talk about another topic that really came out of nowhere until a couple of years ago. Early in our days, we worked with EDS a lot because they had been considering going into the business of providing managed services for Linux clients. Again, a market that never really happened in the United States, and they've been doing a huge business, I think 4 or 5 billion a year, in managing Windows PCs. So they basically told us all of their pains, all their gripes, all the issues associated with managing Windows machines at remote client sites, and so we incorporated quite a bit of the lessons learned into that. So here we are now, 4 years later, and managed services is becoming a hot topic again. So how can an independent company make money using systems management software? Well, by offering an alternative to having their own employees do it. So basically, there are a variety of, depending on what your software does, of services that you can offer. So an example would be updating their system / provisioning them. Again, this can all be done remotely. And you might say, okay, well, for $300 a month per server, I'll keep it up to date, and $50 per desktop, I'll keep it up to date. And those are comparable prices of things I've heard some people charge. I was at the MSP Alliance conference last week, and so there were a bunch of MSPs from across North America, primarily again focusing on Windows, because that's what SMBs focus on or have, but we're doing this especially overseas in Asia. Other examples would be remote monitoring. So instead of the trigger going to an employee of the company, having to go to the service provider, who then figures out what's wrong with the machine, takes preemptive action, and delivers that as a monthly fixed price. Remote backup and recovery is another example, and asset discovery. And so here's a monthly report. This is important for a couple of reasons, which is many MSPs charge their customers by the month based on the number of machines under management. So being able to say, yes, you did too have 187, not 122. Here's the report to prove it, and here's the bill to go along with it. And one thing we're doing with Intel, I think I mentioned they basically OEM some of our software for the Indian market, which is targeting educational institutions. And they basically sell this bundle of software, which includes not just some of our software, but also a school database registration engine, grading system, content management, courseware delivery, and all that. And so how do you have service providers who don't know very much about the application be able to support their customer? And by abstracting as much from the VAR, who typically had as their value added a screwdriver until then, now all of a sudden they're in the solutions business. Well, you need to have a service provider on the back end who can support this first level channel partner. So basically through a series of hierarchies or direct links to any system, you can keep these machines updated and monitored and so on. And again, the concept of labor arbitrage is one where you try to have as few deeply skilled people as possible, and have those people really utilized to the max. So by having a web-based type of architecture, you can have an expert in Bangalore who understands Oracle very well, and someone in Des Moines who understands another type of application, and have them service multiple customers regardless of where they're located. So something that we're starting to see is software as a service. In the concept of systems management, so we all know Salesforce.com and a variety of others, and so now there are some companies that are offering monitoring as a service. So I don't know where these numbers came from. I confess I plagiarized this slide from somebody else, but basically their point is that the larger companies will feel very comfortable having their own IT organizations implement this in-house, And for others, you might want to simply point a browser to a URL and then type in the various DNS names of the machines you want to have monitored, install an agent on them, and basically no longer have to house the system management software. And this is, think about Siebel versus Salesforce. I think we all know what the trade-offs are. And I'm not saying that this is here yet. It's here in a limited number of instances, but I think it's a growing trend. And I suspect that within a year or two, this will become much more predominant. So, avoid having to buy hardware, avoid having to buy software. Instead, have everything taken care of and you just write a monthly check. And some of the pros and cons, again, think of Siebel versus Salesforce. I think that kind of says it all, where you can basically defer the acquisition, not have to have the skill in-house and so on. And basically, here are some reasons why you want to have it as a customer. Here are the concerns that you may want to have. So integration with other components, do they offer it? Security, is my, in the case of Salesforce, my customer base and all my prospects are housed at someone else's facility. Well, for some companies, that's acceptable and it's become de rigueur. And for others, it's still something that is, scary as heck. Same thing, therefore, with information on your systems and access to your systems and so on. So another concept that I'd like to introduce, which is, I'm mentioning it more in the context of a parallel with open source than I am having to do with systems management, because it has very little to do with systems management. But it's the concept of intercompany collaboration. So let me start. It's an animated slide. So if we take a look at, again, where are the costs in systems? Basically, 2/3 of the costs have to do with labor, whether it's internal employees or outsourced development/IT, and you can see what the various other components of the cost of the life of the system are. And so this is a pretty recent survey done by Gartner with top enterprises. And if you take a look at the headcount dollars and you expand it, very little is added toward innovation. Most of it is run-of-the-mill maintenance, the necessary hygiene that has to take place, and so on. And so if there was a way of collapsing that, this would be good for the whole IT community as a whole. And so, this is more, I'm going to skip those details. It was more part of the presentation related to VCs. So let's take a look at how open source models works. Basically, it's people sharing code, and there are a large number of successful projects. We all know what it is, and typically the business model is that it's trickle up. Oh, I'll download this, I'll install it here, and before you know it, a CIO will realize that they have lots of open source, that it's not supported, so they'll get a support contract with Red Hat for JBoss or whatever, Oracle for Red Hat now, etc. What we've introduced is something we call Open IT, where we have established relationships between enterprises, and they're sharing not code, although it could be code, but it's also best practices, lessons learned, how-tos, and so on. So what we'll find is we've signed up quite a few big names already. So Sun, Ricoh, Sanmina, Aero Electronics, and so on. And these are companies that are actively participating where OpenCountry is acting, or a subsidiary is acting as a facilitator. So when you take a look at how IT organizations are budgeted, there's the concept of above the line and below the line. So here are the projects that I have funded, and at one point I'm running out of dollars, and I still have other projects I'd like to get to, but I never get to. And if you have a way of abstracting that and having customer A be able to see what peers of theirs are doing without knowing who those peers are, they might say, well, gee, 4 of us are working on a single sign-on project. I bet 2 of the same vendors are the same, so why don't we collaborate and basically see if we can reduce our costs. So instead of each of us spending $1 million, let's each chip in, if there are 5 of us, say $300K, because there's going to be some overhead, and we'll get something better, and this is something that we've been doing. So we view this as analogous to open source, and it's something that a subsidiary of OpenCountry has been doing very successfully.
I've seen this done with distributed wikis also. Is that, I mean, it just seems
Well-
that that seems done that way. The only issue that seems to come into the organizations is what are we allowing to leak out and what do we not want to leak out?
Right, and so you're talking about implementation of how the collaboration takes place.
Okay.
What we've done, which is very relevant, and we have to keep track of that, of course, but the more important thing is the legal infrastructure. Because what's happening is that these various companies are contributing to OpenIT a lot of their internal intellectual property that they've developed. So as an example, Sun Microsystems has a enterprise-wide monitoring dashboard that they've created over years, spent millions of dollars on it. You have dozens of large customers who've strong-armed Sun into letting them have it. It's not a released product, and now Sun IT is kind of doing maintenance for all these other people, and they'd like to avoid having to do that. And so this is going to be one of the projects where all of a sudden people who join OpenIT Forum and pay to join, I mean, it's not cheap, you know, it's from anywhere from 40 to 100K per year, and you have access to a certain number of projects, then they're going to be able to leverage their efforts, maybe put in more money to do some maintenance, but then everybody wins in the long
So
run.
your consortium building.
Yes, I want to give this software to OpenIT. Yes, I'll loan this one, but when I'm done, I want to take it back and nobody gets it. No, I never want these companies to have it. Yes, I'll let these companies have it, and so on and so forth. And so it's all templatized and makes it easy for a treasure trove of projects to be put into this environment. And so at one point it will become, I mean, very soon, think about if another 10 companies join, which we're expecting in the next month or two or three. All of a sudden, think about all the various internal IT projects that have been done that would be able to be benefiting the end person joining. And so we think this is just a huge business opportunity for us. Yes?
Do developers tap into that to see what the direction of the industry is, or anything?
Well, to the extent that developers are part of our employees, the companies who join, yes. But again, developers are, I'd say, a small part of the effort here, because code is obviously critical, but business processes, experiences with vendors, how to avoid, if I'm going from SAP X.Y to X.Z, how do I avoid paying through the nose for them to consult? And so a lot of it has nothing to do with code, but some of it certainly does. So this is a really top-down driven, because these are now IT organizations who say, well, gee, if I join an OpenIT Forum, look at all the projects below the line that I can now fund by simply leeching off of what others I've done, or figuring out what else is out there, what have people done. And there's so much repeated problem solving and solution creation in the IT environment. It's phenomenal. I mean, there's so many companies that work on SOX compliance and this and that, and internal security policy, and how do you regulate wireless usage in your company, and relatively little of that is code.
But this also works for almost any content creating industry.
Yes.
Right. So that means education.
Yes.
Media,
Yes. Yes.
Anything you're willing to basically put out there.
Exactly.
Yeah.
So let's talk about another form of entrepreneurial collaboration. So I was giving a talk in Portland a couple weeks ago, and I was invited to present to people from an organization called Posse, which is the Portland Open Source Software Entrepreneurs. And so I show up and I ask them a question, who are you guys and what do you do? And what it is basically a couple dozen companies who are all focusing on delivering services for open source, sometimes software development, sometimes just maintenance of existing systems. And what they're finding is that they tend to be small, 2-person companies to 12 or 15-person companies, and for them to have any kind of credibility in their local market, they'd like to provide assurances to their client that, hey, if you hire me as your consultant, as your outsourced IT, as the problem who needs to put these various components together, and if I go out of business or I get hit by a truck or my whole company gets destroyed in fire, guess what? Here are other members of this organization who got voted in by other members who are trusted peers that you can go to. And I thought the concept was phenomenal. So here all of a sudden, it gives parity with small, very entrepreneurial organizations against much larger ones, where if you're dealing with a company with 1,000 people and they have 500 clients, well, you're saying, well, the likelihood of that organization going out of business is relatively low compared to John Doe, who's really good, and he's my neighbor, and I really like him, but he only has 4 employees. And so this is one thing I thought I'd want to mention, just because I know a lot of you are entrepreneurs involved with wellness providing services and all that, and I thought it was pretty interesting. So possePDX.org is the URL, or if you just type in Portland Open Source Software Entrepreneurs, you'll get there. So just about to wrap up here, I have a few slides which, okay, so now we understand the basics of systems management, hopefully, as at least viewed by us, the various ways of delivering these services. So what are some of the lessons that we as a company have encountered? So first of all, even though we think it's intuitively obvious that you should want systems management, some companies don't. And so those who do it to lower their operational expenses. They believe in the return on investment. They like the idea of their infrastructure being predictable. Some of them focus on compliance, others don't care. You'd like to be able to grow without having people. You'd like to make sure that if my guru, sysadmin John, gets hit by a truck or gets hired away, that all of the institutional knowledge that's in his brain doesn't get lost, and all of a sudden I'm left with a pile of scripts and a bunch of systems I don't know how to operate. And so that's really fear is the motivation there. And also in environments where they haven't had Linux before, either because they're adding, they're all Windows or Square shop, now they're bringing in Linux, or it's in the case of what we're finding overseas, organizations that are brand new that are being deployed, whether they be government institutions, education institutions with computers for the first time, or maybe the first refresh in 5 years because they're going from Windows 3.1 or something. And so those are people who are much more likely to embrace systems management. So why wouldn't everybody? Well, I'll just tell you some reasons that we find. Institutional inertia, gee, we're doing it fine. The building hasn't caught fire by doing it the way we were doing it, so why change? I'm really short on cash. My business is a 3% gross margin business, and I just can't afford a dime, unless the building is on fire. I'm not going to invest anything. You've seen those. Another thing we run into is the fear that certain sysadmins have of their IP and their value being diminished in the eyes of their management. And that's why part of our software allows for the incorporation of scripts, which is a form of intellectual property, and if anything, empowers the existing sysadmins to focus on below-the-line projects and not have to deal with as much overhead taking care of the day-to-day systems. But this is very often what we'll find is, actually I have a slide that addresses that, I think, coming up. So, which brings me to cultural and geographic maturity differences. So, US scenarios happen to us more than once, and I'm sure it happens to every systems management company out there. So, IT management gets convinced that for compliance reasons, for scalability, for business continuity, they need systems management. So they say, okay, John, you're the expert. Go ahead, prove the ROI, and come back to us and we'll make a purchase. So we all think everything is fine. And then he says, well, gee, I don't really see the ROI there, and if I just write, a few more scripts, I can kind of get there, so why don't you save your money? And because of the American culture, management, well, including myself, I'll never question, what my sysadmin tells me because he's the expert, and so if he says, no, this really won't do the job, I'll believe him. And, we empower the people within our organization. So, bottom line is that in this particular scenario, they wouldn't buy systems management. Luckily, the majority of the time, this phenomenon does not happen, and they are enlightened, and the sysadmins realize that they are going to be saving time and not having to work till 10 o'clock at night, 6 days a week, and can have more normal lifestyles. But there's still plenty of this time. Whereas Asia, and this is why we're actually generating more revenue in Asia than we are in the United States, is you convince management that they need it, and here's what the ROI is. Management will say, okay, Kern, go and prove that this is right. Does it indeed do this? Does it indeed do that? And so they'll go ahead and say yes, 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 and then basically they'll buy it and it'll be used. It's just an incredible difference. So what's the lesson learned there? Is twofold. US empowers the individual a lot more, that's a cultural thing. And there's another element, which is systems, including and especially Unix, have been managed for a long time using scripts. So there's institutional knowledge that gives more comfort and more ability for the person who's been doing a good job at that to say, hey, we don't really need stinking system management software. And on the other hand, what we're finding is that in China and India, they're trying like crazy to catch up. They don't have this institutional knowledge of systems management done by scripts for decades literally, and they're open to new ideas. And so that is one of the reasons why actually China is where we make the most revenue right now, and that's where our biggest pipeline is and everything, because we've teamed up with Turbo Linux and CS2C and Co-Create, and whenever there's a bid coming out, Red Hat will maybe win 1 out of 5, and the local distros will win the other ones. Yes?
Maybe you mentioned this already, but are your slides available on the net?
I could massage them and email them to Bill. There's some I'd probably want to remove, but when we do that?
It's time to turn the 20 into 30.
Yeah, I guess I was looking at my own, yeah, you're right.
You probably
I was doing Unix in college
animation
in 77, so.
Yeah, exactly, that's what I'm doing.
So finally, the title of the talk was How does Systems Management Accelerate the Adoption of Linux? So it really has helped bring legitimacy. I mean, Solaris has had rock solid hardware for a long time underneath it. Fair number of management software, a good reputation, high volume transaction throughput and stuff. And so, Linux is now legitimized when you combine it with the commodity hardware. Also, I mentioned the war stories of enabling government-funded, that's the key thing, Linux distributors in other countries to win against the big bad Americans. And therefore, bids involving Microsoft and Solaris are fewer, and it's more, okay, we want Linux, and depending on which, in the case of China, if you're the railway ministry, you have your favorite systems integrator, and they have their favorite Chinese distro, and if you're city of Beijing, it's another SI with another distro, and we support all of them, so that's what we're doing. And another one, and this one could be argued, that the total cost of ownership, once the software price comes out, it further accentuates the percentage of labor as a system and as the total cost of ownership over 5 years. So anyway, that's it. So time to shoot me the threads, pick me apart, question me. Yes?
Well, a long time ago, I heard and kind of explored the idea that in a static organization with the fewest possible system administrators, you basically have one administrator for 100 machines. That's where the labor, that's the minimum amount of labor you can get by with. But when you use your software provisioning solution, what do you see instead of 60% labor for the total IT costs? What do you see as the approaching limit as this solution begins to work to its maximum? What seems to be the asymptote for the percent of labor?
That's hard to quantify because it varies, as you said, based on the stability of the environment, the type of business and everything. I'd like to think that systems management, when it's properly applied, could probably remove a third of the labor component. So instead of it being 2/3,
It becomes economically advantageous to choose this solution when you get how much savings?
Oh.
A couple percent?
I would say if you have more than a half dozen systems, depending on the price of the software, you'd be, you really ought to look into doing this. And the price points, at least in our case, are very low, so we're trying to encourage people to do things a different way. So for example, to manage up to 9 machines, we give the software away for, I think it's $800 per year or something, to manage up to 9 machines. So that pays for itself in a month. And then once you get into hundreds or thousands of systems, the price goes up to some extent, because it's no longer the bottom basement, the loss leader, but still to manage 100 systems per year, software would cost around probably $20,000 or something like that.
There's kind of the X factor in organizations. He's talking about the below-the-line projects. Those are all the projects that go out and make money for you. They're kind of bogged down maintaining the stuff you have.
Yeah.
So as you free up the skills that sysadmins, they're the ones that make that stuff happen.
Well, what I was thinking about is a friend of mine a long time ago gave me a model that software is like the plants in a garden. And you have to keep going in and pulling them out and getting the weeds out and all that stuff. And the hardware just lays there like a piece of wood logs in the back. And what I was thinking to myself is, this makes it easier to plant whole fields of software, but there's this basic churn factor. I went to the latest Ubuntu, and so many damn things on my system broke, I wasted 3 days fixing it. And so much for an upgrade, you know.
Yeah, we heard about that. Let me guess, X Windows disabled, was that the one you had? Or?
Yeah.
Yeah, that made a fair amount of noise. And again, as a consumer or a non-enterprise environment, there's nothing that can be done because you have to have more than one machine or more than a handful, and you have to be using it for business purposes. We signed an agreement with Ubuntu, and we're now on their website, and they endorse us as the system of choice. Yes, sir.
So earlier on in your slides, you were talking about configuring new nodes for provisioning, and you had a little checkbox that was provision always, provision none. How long till you add a provision the first time or one time only, so that those people installing those Oracle databases that you gave us an example, it automatically flips to no after the first?
We've talked about it, and it'd be a very nice to have, so thanks for pointing it out, and it's kind of low on our priority list, because it's a one-time event, so it's part of the policy that you go through, okay, go to the freezer, get the box, install the OS, click this, and then unclick that, and then you're done. So, and then just think about the amount of QA necessary to really verify them in their own conditions, and so that's how I look at it. Plus, we support 20-some distros, and so there's a multiplier effect where features are have to be put in, and we have to weigh the cost of having them on an ongoing basis. And it's not easy to support as many distros as we do, but that's part of the reason why we're successful. But it's pretty costly in terms of QA. So we have, I won't mention the numbers, but we have as many QA people as we have software developers. And we have lots more hardware than we should have, but that's part of our business. Any other questions?
Is your software like a web-based application?
Yes, it runs on JBoss.
Awesome.
So all you need is Mozilla and credentials, and you can go ahead and away you go. Okay, well, no more questions. Thank you.
Thank you. Thank you.